Want to nail engineering manager interviews at Mang and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into Mang. You could be next. To learn more, register for our free webinar.
Hey, Matt.
Hey, how's it going?
It's going pretty well. How about yourself?
I'm doing pretty good. Yep.
Awesome. Great to hear it. So yeah, first things first. In the invitation to this interview, you should have also gotten a link to the code bunk. Beyond that, this is going to be a 50-minute interview focusing on trees. So hopefully that is, what you were correctly signed up for.
All right. Sounds like a plan.
Awesome. Sounds great. And then, yeah, so in a couple of seconds, I'll go ahead and paste in the prompt. Feel free to ask me any questions you have about it. And as much as possible, try to sort of walk me through your solution as you work on it, both to help me kind of get a sense of where you're at and possibly provide guidance, and also to, help guide you through the problem as well. Okay, with all that said, I'll go ahead and paste it in.
Okay. Given the root of a binary tree, imagine you're standing on the right side of it. Return the values you can see ordered from top to bottom. Okay, so from root to leaf on the right side, correct?
Yep. There's also, I guess it's self-explanatory, but there's also an image attached to this. So if you wanted to go ahead and open that up, that would provide some insight as to what this actually looks like.
All right. So what I'm thinking about is using a level order traversal, and I'm going to go through each level, and I'm going to make sure that when I'm adding to my result or the output, as I go through each level, I'm only going to I'm going to have like a temp array for each level in the queue. And then in order to get it into the result, I'm going to just append the last item of the temp array into the result for each level. So for the first level, when we throw in the root, the last item is going to be the root, and then we'll get 2 and 3. I think so. Yeah, then we'll get 2 and 3. And since these are both going to be in the temp array, I'm only going to append the 3, and then we'll go through the 5 and the 4, and I'll only append the 4.
Yeah, I think that makes sense.
Okay, I think I'm going to go ahead and give it a shot then.
Sounds great.
All right. That we'll say define right side tree thrown in the root. Okay. And so if I'm throwing a null tree, what would you like me to return?
If you're throwing a null tree, just return an empty list.
Okay. All right, and then this is going to be the result array, which we're going to return at the end. And then we're going to have let's see, we can throw in the root right now because we've already checked if it's null. So we can start our queue up. Oops. And for the nodes, I'm gonna do node.val, node.left, and node.right. Is that fine?
Totally makes sense to me.
Okay. And then q equals, yep. And then we're gonna say, so we've thrown in the root, and now we want to do the level order traversal. So we'll do While the queue is full, number of nodes is equal to length of the queue for. I don't know if we need to really track this next one. We'll keep it blank for now. I can change it later. Range of num nodes. So we need this as well as our temp array. So this is how we'll differentiate between the levels. So for the first level, we know there's only going to be one in here for the root. And we'll say, okay. Blank in the range of num nodes. We want to add it to the queue and the temp array. Dot append. Oh, we didn't pop it. We're gonna pop it here. I'm gonna add it to the temp. And then we're gonna add it to the queue. But no. Queue.pop left. No, just queue.pop left. Oh, sorry, I drew a blank. So it's the if node left. So if the node left actually exists, appended to the queue. If node right exists, appended to the queue. So we're appending the node to temp. So this is the end of temp at the end of this for loop. So this is the end of the level. And when we get to the end of the level, we want to do result dot append the last value of temp. Okay, so we go through the level, we append it if it exists, then we append it to the result. Temp is reset when we reset the queue, which is good. All right, I'm gonna run through a test case. So we're gonna run through with this input here or this input here. So we're gonna be thrown in one. One goes into the queue. We get the length of one, temp array is initialized, and then we're going through in range of one. We're popping out the node. We're appending the root to temp. We're checking to see if node.left exists. It does. So we're appending 2 and 3 to the temp, or sorry, to the queue. So 2 and 3 are now in the queue. This for loop is now over. So now we are appending the last element, which is 1, to the result. Next, we are going again, we're going to pop out 2. Temp array is initialized for blank in the range of 2. We haven't popped it out. Sorry, we're getting the range of num nodes. So now we're going to go twice. So the first one is 2. We're appending 2 to the temp, checking to see if it has anything there. It doesn't. It does have something here. So 5 is added to the queue. And then we're going to go down again. We're going to pop out 3. 3 is appended to temp. Node is checking to see if left exists. Nothing's there. 4 exists. So 4. So now we have 5 and 4 in the queue. And 3 is the last element. So we're adding that to result. So right now we have 1 and 3. Last but not least, we'll have another range of 2. Empty temp, pop out 5. We'll pop out, add it to the node, check to see if anything exists. Nothing exists. And then that should be good. Yep, add the last one. Okay, I'm trying to think of edge cases now. We got the invalid tree If a tree of 1 is thrown in, it should be the same. All right, I think this is a good answer. I can't think of any other edge cases.
Yep, totally makes sense to me. If you wanted to go ahead and try running your solution on just the example input, that would be awesome. And then just printing that standard output to console.
Okay. Do I have to set up like a tree class to run this?
Mm, nope, it should just oh, I see. You're just being handed in the same array format.
Oh,
So it's
I
just
see.
being handed as the array. So you do need to also do the construction of the array into the proper format.
Okay, so we need to make a class for node then. We'll have should be define the init just thrown down self, and we're gonna have probably the value, we'll keep it val, and then node dot left or left, right. We can keep these as none. Default. And then we'll say self dot val is equal to val. Define the next function. No, we'll define the left function found in self. And I think you just need self for this. We can edit it later. If node dot left exists, return, oops. Since I set the class up this way, I can probably remove these conditions. Just because I have my own custom class.
Yeah, it totally makes sense.
Self dot right. Okay. And then, so left, right. Yep, that makes sense. So then, now that we have that, is this in order?
Yes, it should indeed.
Okay. Yeah, we may add more to that class later, but for now, that's good. So now we need to deserialize the array. We're thrown in an array. We're gonna just call this deserialize. Okay, we're throwing in an array. And we're gonna return a node. Okay, so then we want to loop through the array that we are given. So for I in range of the length of the array, if I is not equal to null, is it actual null or is it none? Or is it just like the string of null?
Ah, I see. You can change it to none. I think that makes more sense here for the Python case.
Okay. So if I is not equal to none, no, this is not going to work for the in order. I need to do like a DFS traversal, I think. Let's see. Throw in one. Then we have these two. I think
I also believe it should actually be in, it should actually start with the root, so it should be in pre-order, not in order.
oh, okay.
Because the test case given here is the same one as the image. So it starts with the one followed by the left and then the right.
Yeah, 1, 2, 3, and none. Like, okay.
Yep.
Let's see. So if we want to turn that into a tree with knowing it's in pre-order, we can, I'm gonna try actually doing a DFS traversal on it. And we're gonna be thrown in the value in the node. Call that node for now. And at the end of the DFS traversal, we're gonna return the root.
Makes sense.
And then for I in array length and range of array. Okay, and then we're gonna say DFS the I. No, that doesn't seem right either. Because we run this, it returns a 1 immediately. We need to throw the array into the DFS. So the deserialize needs to be then we're gonna say if array is equal to 0, length n is equal to length of array. If n is equal to 0. You keep wanting to iterate, but we're not going to be doing that. What we're gonna do is we're gonna say we're gonna create a tree node on the first value. Now, I'll just stick with the iteration, see how it goes in range of the array. We'll create a tree node on the I. So this is the value is equal to node is equal to that. And then we want to put node I can't believe I'm missing this. What am I doing wrong here? Node the D. I know for a fact I need to use recursion, but it's not coming to my head. So we define this here.
Since we do have quite a lot of time, I'm just stepping out from helping too much here. But feel free to ask if you have any, specific things you're wondering about here.
Gotcha. I'm gonna give it a little bit because I know how to do it. I'm just kind of drawing a blank on how I go through the array to deserialize it, but I may tap out in a second here. Let's see.
Totally makes sense. No worries. I need to mutate the array as I go through it. So I think it is the DFS call. And I think I'm going to be throwing down the array, but we'll call it like the tree. And then I also want to be thrown down. No, we'll just keep with the tree array. Okay, so we know when we call this, we are going to be throwing down the array. And what we want to return at the end is probably just what it returns. And then as we go through, node is going to be equal to, we'll keep the index at 0. So node is equal to tree node I. Is it possible the root node, they would give me like an invalid tree that way? Can you explain sort of in what way you mean?
Yeah, this would be none, a null node, and they would be two disconnected graphs basically.
I think you can assume that it is a valid tree.
Okay.
So no, you can assume the first element in this array is going to be not none.
Gotcha. Okay. So node is equal to tree node I. Well, if tree array I is equal to none, just if not tree node I, return none. Okay, and then we're going to say node is equal to tree node I, and then node dot left is equal to DFS tree array the tree array. Then I plus 1, because we know it's pre-order. And node dot right. Go DFS, and then we throw in the tree array. I plus 2. If I plus 2 is less than n. If I plus 1 is less than n. So we create the node, then we do our recursive call adding 1. So then node left would go. But this is not going to give me the pre-order. I don't think so. Well, yeah, maybe it will, because it'll give 1, 2, but the third one, which it's going to look at. So the third index is there. Oh, wait. I think I see it now. I see it now.
Mhm.
Okay. So
What do you think it is?
we're not going to be doing indexes. We're going to actually be popping from the array. That's how I'm going to mutate it.
Sounds good.
So we want to do tree node, or we'll just keep it as current is equal to tree array dot pop 0. And we want to check to see if length of tree array is equal or less than or equal to 0. Should never go under 0, but just in case, return. Just return. We'll look at that one in a second. The current one, we pop the leftmost value. And then we are going to set this leftmost value if it's not equal to null. And then we're going to say node is equal to tree node of cur. Node dot left is equal to DFS. Yep, same tree array. Node dot right is equal to the DFS, same tree array. Yep, because then it's going to pop and then node left will go through. Yeah, this should work. And then we're going to return node.
Awesome. I think that logic makes sense.
Okay. Well, that's the, now we have the tree nodes. Now we just need to add it here. So this is actually given an array. Let's say root is equal to deserialize the array. Okay, we won't change these just yet. I want to check out the deserialize first. Right. Oh yeah, there's nothing gonna print out.
Go ahead and just add a print statement around it.
Oh,
Ah, makes sense. Might just need a 2-string argument in the class itself.
for Python? This is, I think the issue is I'm actually like appending the node itself, like the class, but I need to be
Oh, I
appending
see.
the
I see.
value. Yeah,
If you just do the value, it'll work that way. I see. I see.
yeah. Yes, I think this should work now. 1, 2, 3, 5, 4. That's not correct. Okay, so
Mhm. It seems like what currently happens is that it just traverses it returns the traversal of the tree, but excluding those none nodes.
yeah. So it's something wrong with my appending here. So one goes through. Okay, now I'm a little confused because we appended it, appending it. Where is dot append?
I would say here to start by at least double checking the output of the deserialization.
Yeah, I think the issue's here too. In order to, we need to. Well, no, we need the null node itself. I guess the Python implement. Okay, we'll just do node.val.
Makes sense.
I also have left here. I was looking at the. Oh my goodness, none type object has no type val. Oh, is it this one? Did I forget to check? That's not possible. If it exists. Thank you. Wow, it's very weird. Okay, I think it's just because I had left down here. So share with all, so 1, 2, 3, 5, 4, 4, 5, 3, 2. That doesn't seem right. Okay. Yep, so the issue is definitely here in the traversal. Okay, so we're going down. I think the issue is I'm thinking it's in order. It's not, it's pre-order. That's my big issue. And I forgot how to, I don't even think you can
Mhm.
set up the tree from just pre-order.
So there is actually a subtle difference here, which is that this is essentially, I guess just to give a little bit of guidance, this isn't the same order that you would think about it if you're thinking about it in terms of each level at a time. So if you were to sort of read the tree level by level, this is the output you would see. So you would see first the 1, and then 2, 3, and then none 5.
Oh,
4.
I see. I see. So I think we actually don't even need this then. That was kind of, if we just use, we know for a fact the nuns will be filled in. So what we can do is have like a tree max tree range and starts at 1. So then we'll have for blank in range of max tree range. And then as we go through the queue, we have 1, then times 2 is, so 0 plus 2. So the 0 index, the second index, the third index, fourth index, fifth index, sixth index. So it's multiplying by an exponent of itself. Because the height of the trees n squared. So we just have to square this, unless it's 1, then we add 2. 2 squared. No, what? Why am I doing this wrong?
So I guess one thing, we have about 10 minutes left. And 2, can you explain to me again the solution that you're using that doesn't involve, separately deserializing the tree?
So we know it's a level order traversal, and we know that the nuns are filled in.
Mhm.
So that means we know that no matter the length of the array, like the indexes that we need to hit will always be the same. Because the array is filled with nuns. So we know that for every single tree that we are given, if the length exists, we're gonna have to hit index 0. We're gonna have to take index 2. Unless it's none, but if
Mhm.
it's none, it's a valid tree, so you know it's not there anyway.
So what if we, I guess, what if we took out both 3 and 4 here? Then you would be looking at index 0, index 1, and then it would, or depending on whether so if we were to take nodes out of this tree, depending on whether we took out 2, 5 or 3, 4, you would either be looking at index 0 and index 1 as your sort of 2 nodes left in the tree, or index 0 and index 2. Does that make sense?
Can you run that by me again? Sorry.
Yeah, so imagine we either took out the left branch of this tree or the right branch of this tree. Either way, it would be a single straight line tree, but it would be valid. And if we were to take out the 2, 5, so we tested on just the tree of 1, 3, 4, then we'd be looking at index 0 and index 2. Whereas if we took out the 3, 4 and left just the 2, 5, we'd be looking at index 0 and index 1. I don't agree that we'd be looking at the same index every time.
But when the array given, like these would be none still. So like the index of the input array, wouldn't that still be like?
Oh, I see what you mean. Yeah. That is indeed correct though. Or wait, because if we were to take, yeah, so let's try writing this out, I guess. So if we have the basic input as being as here, 1, 2, 3. Like pull up the image of the tree again. apologies, 1 second while this loads. So we have 1, 2, 3, none, 5, and then it would be none, 4. So if we were to just take out the, as I said, the 3 and the 4, then we'd be looking at this. So the ones you'd have to consider would be your 2 sort of right side nodes here. I guess taking out this as well.
Oh, I see what you mean.
But on the other side, so in this case, we're looking at just the right side view is index 0 and index 1. But on
Yeah,
the other end, it's going to be, we take out the 2 and the 5. And then we're
Yeah.
looking at index 2 and index whatever the last one is there. But focusing on that 2 and 3, depending on which one is available, you're going to either be looking at the first or the second.
I see.
So I will say, while we have, a little over, I guess, 5 minutes left. I do think the deserialization function is probably the easiest way to do this. I think there is a way that you could do it all in one loop or with the base array, but it would be a lot trickier. I think it's very possible if you kind of zoom in on how you're doing the traversal in the deserialization and try a different method there.
Yeah, I was thinking like my last stitch with this max tree range, I was gonna put this in the deserializer and then I was gonna do a BFS traversal. And the BFS traversal, like this would be the max range as I'm doing the deserialization. Because then I know, like, as I'm appending the nodes through this, I know like for each level, each left and right node as I go through it, because there's no other traversal that can
Yeah.
do that other than the BFS.
Yeah, I totally agree. I think that would be a good solution to this problem. Or to this problem within this problem.
If I didn't have to do that, like if I was given the root, this would work though, right?
If you were given the root initially as the input, then yeah, that would have worked.
All right, sweet. I got half of it then.
That's fair. That's fair.
I'll take it.
Yeah, you still have about 5 minutes if you wanted to give that.
Oh, okay, let's try it. Yeah. Okay,
Yeah.
so BFS, and then we're gonna do the max tree range is equal to 1. Let's say Q. Well, we'll put the Q. We don't need this actually here anymore. Drop that, drop that. Tree range is that, and then we'll have Q is equal to this. I'm gonna get rid, no, we'll keep that for now, save us some time. And we're gonna throw in the array. Array dot pop 0. Oh wait, we can. No, just stick with what I'm doing. Array dot pop 0 is equal to the current. Wait, what? Okay, we'll just, I'm kind of losing my mind for a bit there. I can't do the math right now. For that, in range of that, we'll say tree node. So we go through for each range, we're attaching the nodes. And then we, I still don't think this is the correct math for that. And I'm not appending the left and right. Yeah, I think I ran out of time to do this. If I had this idea first, it'd be better, but
Yeah, definitely. I think that totally makes sense. Cool. Well, in that case, I'm totally happy to hop to the feedback. Yeah, I think overall you did quite well. This is a relatively difficult problem, and I think you found out why pretty soon into the interview, because the actual traversal isn't that hard. It's just the constructing the tree from the level order traversal is tricky when you're given a sort of raw list and aren't familiar with it. But you did ultimately hit on the solution at the end, without really any other prompting for me than saying that you need to change the traversal, which in this case is to just do a breadth first search, excuse me, a breadth first search traversal. And just like you said, you already know the number of nodes that are going to be on each level of the tree. That's just a given. You can generate that number, which I think you're pretty close to doing. And yeah, it was just a matter of, having that solution in time. As far as sort of, so I think strengths, definitely the explanations you were walking me through were super clear, which was awesome to see. I didn't really detect any particular nervousness, which is also great. Obviously, that's a somewhat easier thing to do in an interview with less stakes. But regardless,
Yeah, that's true. Yeah.
yeah, great to see regardless, even in the practice. Obviously, that's not a skill that everyone has right from the get-go. And then another thing was just, like I said, you were pretty much on the right track for most of your development. So there were definitely parts at which, I kind of stayed away from giving you too much input, because definitely for a majority of the interview, you were working towards something that was helpful or something that would have been, a viable solution if a more difficult one. And then I guess things to work on. A little bit on the debugging. I think what would have been helpful is, one, getting some print statements into your deserialized function very early. Obviously, interviewers kind of vary on how they feel about it, but I think a practice that I've seen done more and more by successful candidates is kind of preemptive logging of a lot of things. So instead of just waiting to the end to sort of get to the point where you can execute the code fully, and then adding in print statements to debug afterwards, just putting in logs up front when you're developing things, so that you can have a first draft that already includes some methods to debug it without even having to change the code. So I think that's a great strategy that would have been useful to incorporate here. And then, yeah, other than that, just focusing on kind of learning more about the ways to construct these lists, because, yeah, that kind of serves a dual purpose. If you spend some time studying how to serialize and deserialize these lists, in that, one, there's a lot of interview questions that are mostly, if they're about trees, are going to be, half the question is just turn this list into a tree or turn this tree into a list. So practicing that is helpful for its own right, just for questions that directly ask that, and also for questions like this, which ask it a little more indirectly. But yeah, that was about it for the quick feedback. I'll be submitting a more detailed scorecard in a day or two that you'll be able to see. But yeah, as we wrap up here, do you have any questions for me, either about this specific interview or the process?
Yeah, sure. So just to wrap up the feedback, it's if you can try to get some logging throughout the solution, especially if you're kind of unsure, like I was through the deserializer, like try to just preemptively log. Really brush up on the deserialization and serialization of trees, because a lot of questions use it. And let's see. Oh yeah, just this is kind of my own, like I kind of extracted this, is like really understand the traversals and how to like deserialize and serialize each of them if you can.
Yep.
And then for the question, I guess like my main question is when it comes to like a tree or a graph question, if I get one of those on the interview, is the likelihood that I get like the other one like high or low? Like if I get a graph question, is the chances I get a tree question low and vice versa?
Pretty low, I would say. I would say from what I've seen of, sort of current interview questions, one, I would say you're usually more likely to see graph. I suppose tree questions are kind of a subcategory of graph questions. But I would say you're more likely to see, non necessarily tree graph questions a little more often than tree questions. And yeah, like you said, if you get asked one, you're generally not going to be asked another one, just because it doesn't follow exactly the same skills, but they're pretty similar a lot of the time. So yeah,
Okay.
usually you wouldn't want to ask those kind of questions back to back if they're pretty similar.
All right, and that makes sense. And I think like for my last question, I know we're running low on time, but so if I were to like just base my skill set, I think my lowest right now is definitely on dynamic programming and like greedy algorithms. Like that stuff still kind of goes over my head. Like I can get the recursive function and I can do the brute force, but to me to do like the memoization with the snipping of the branches like that, I can sometimes get the top down version of it. But when I need to do bottom up, I feel like I'm more often just memorizing the question than I am like understanding it. Like this stuff I understand, the graphs I understand, 2-pointers, get that. But for dynamic programming, I feel like I'm memorizing more than understanding. So do you know like I know there's no such thing as a quick trick to learning, but is there like a better way to learn dynamic programming? Am I wasting my time? Like,
Oh, sorry, I was muted. But yeah, I think so. I think you asked both about dynamic programming and greedy algorithms. I think greedy algorithms are a tougher one out of those two, definitely, just because I think greedy algorithms are the least descriptive of a solution. In that usually it's kind of just a different way of going about. I think greedy algorithms are only a little bit more descriptive than saying brute force, in the sense that it's a definition for a class of problem where you're just you're kind of taking whatever the most easily available option is. So
I feel
a
like
lot of greedy algorithms are going to be things that are kind of memorizing, in that you may have seen if there are super archetypical and super common problems, then you might want to learn those, and they might have offshoots. But my general advice is not really to worry about specific greedy algorithm problems until you have a firm grasp on most of the rest of the types. And sorry, I think you were going to say something.
yeah, I just feel like in order to do a greedy algorithm, you need to have seen that type of question before. Like it's not like you can apply this to a broad swath of questions like you can with the BFS traversal or anything like that. Like you need to say, okay, this question is very similar to this, so I'm going to use this greedy algorithm.
Yeah, exactly. I totally agree. And it's it's a thing where that's kind of why generally those questions are a little bit less asked, and also when they are asked, there's more leeway for kind of it'll be a bit of an easier problem that you'll have more space to just work through on your own, to give you a chance at getting that kind of intuitive solution. I would just say for greedy algorithms to kind of go through the checklist of like sort of the available different types of problems you could think of. And if none of them seem to be coming up, then try to look for an intuitive solution that's more just based on those greedy strategies of taking the most available or the most valuable option first, and then just following from that. On the other end, what to do for dynamic programming problems, I think those are much more studyable. I think the key with dynamic programming problems is one, being able to kind of spot them, which is just based on some heuristics of the problem, looking for things like you're accumulating amounts of things, or you're trying to find like maximum values a lot of times, things like that, or occasionally path-based problems that aren't in graphs. So if you wanted to find the
Robot
best,
path, yeah.
yeah, you wanted to find the best way to get from a point to another point. So first, basing it off heuristics, and then just knowing that in not almost all, but in a large number of dynamic programming problems, what you're going to be doing essentially is just taking the maximum or the essentially the better of two options. And the only thing that you really need to do is determine that recurrence relation. So figure out how you compare two options to see what the best would be, assuming that you already know what the next step would be. And then just build it up backwards. So that was a lot to say in an interview that wasn't really about dynamic programming, but you know, I'm happy to answer more questions, I guess, on via email. But yeah, I would say that that's my super high level overview of how you would go about studying for that.
That does help. And I think maybe I just need a bit more time on it, and then I'll get it better. All right. Well, this was really helpful. I really do appreciate this.
Awesome. I'm glad you did.